Okay, so this video is for some problems at the end of chapter 19 on delta G. So this is problem number 65. It says classify each of the following reactions as one of the four possible types summarized in table 19.3. So this is not asking us to do a calculation, it's just asking us to look at delta H and delta S and how that would affect delta G. So in the first one, letter A, it shows us that delta H is negative. Okay, that means it's exothermic, and when reactions go to a lower state of potential energy throughout the reaction, that's a favorable condition. A lot of reactions that are exothermic are spontaneous. But, however, that doesn't make it spontaneous, because there could be such a decrease in entropy where it counteracts that and it possibly is not spontaneous. So we have to also look at delta S. So delta S is negative, which means entropy is decreasing, which we know that's not a favorable condition for a reaction being spontaneous. So it's going to depend. It's going to depend on which one is, more affecting the delta G value. So it may be spontaneous. And if we just remember that they're both negative, it will be spontaneous, or delta G will be negative at low enough temperatures. And you'd have to do the calculation to figure out if it's low enough or not. Okay, example B shows us that delta H is positive, which makes the reaction endothermic, which is not favorable for a reaction being spontaneous. However, some reactions that are endothermic are spontaneous because their entropy is increasing so much. But here we see delta S being negative, which means entropy is decreasing, which again is not favorable for the reaction being spontaneous. So because they're both not favorable conditions, this will never be spontaneous, no matter what temperature it's at. And so delta G will always be positive. Okay, the last one is letter C, and we see that delta H is positive, making it endothermic. Again, not favorable. But delta S is positive, meaning that entropy is increasing, which is a favorable condition. So again, this is going to depend on temperature. And we can just simply remember, although we should be able to look at the equation and explain it, that if they're both positive, it's only going to be spontaneous, or delta G will be negative at high enough temperatures. So that's number 65, just looking at examples of reactions and their effects on delta G. Okay, we're going to go to number 66, the next one, and now we're going to do some calculations. So the equation we're using here is delta G equals delta H minus temperature times delta S. And all of these are standard conditions. We have to use standard conditions to use this reaction. So it says, from the values given for delta H and delta S, calculate delta G for the following. So with these equations, we want to be careful with the units. So remember, delta H is in kilojoules, delta S is often given in joules. So you have to switch one of them. Because delta G is going to be in kilojoules and delta H is in kilojoules, it's just easiest to take whatever the entropy is and always just put it over 1,000 in the calculation. So we'll do letter A first. So we're trying to find delta G standard. Delta H is negative 844 kilojoules. And we're doing minus the temperature, which it says here that we're doing 298 for all of these, Kelvin, times the change in entropy, which is negative 165, which I'll just put over 1,000 in the calculation, which will end up giving me kilojoules per Kelvin. So we multiply the temperature by the entropy, we end up with just kilojoules. The Kelvin cancels out, so we're subtracting kilojoules minus kilojoules. Be careful with doing your work that you don't leave out the negative, or you're making sure you're doing the calculation correctly. So this would be negative 844 minus, this comes out to be 49.17, and negative kilojoules. Okay, so we're doing negative 844 really plus 49.17. And so we see that our 49.17 is a smaller value than 844. So it's going to leave us with a negative delta G. So this works out to be negative 795 kilojoules. Okay, so again, because delta G comes out to be negative, then we know it's